we think back to 17a and our recursively defined sequences, when we're at a fixed point, that means that whatever we put in is exactly the same thing that we get out. Well, that's what it means to be at equilibrium, that whatever age distribution we're at right now, we're going to stay there. So whatever n sub t is, that should be the same as the n sub t plus 1. So that's why he's written this side also as n sub t, to show you that we're at equilibrium. Well, to find that vector, I'm just going to put it in. So I'm going to call that xy. And also call this xy. We're looking for any solutions to this system. So on this side, if I multiply that out, I'm going to end up with b times x plus 2y 1/2 x plus 0. Well, thinking about matching these up, that tells me on the top row that x has to be equal to bx plus 2y. And on the bottom row, that says y has to be equal to 1/2 of x. So if we're looking for solutions to this system, I can replace the y up here with a 1/2 x. And this becomes x is equal to bx plus 2 times 1/2 x, or x is equal to bx plus another x. So it looks to me like if I subtract the x over, then I have 0 is equal to bx. Well, that tells me that there are only two possible solutions. One of those solutions is that b equals 0, and the other solution is that x is equal to 0. So if x is equal to 0, then my n sub t vector would be 0, 0. And that's happening because y is equal to 1/2 x. So that's what's going to be true if x is equal to 0, or if b is not equal to 0. But if b is equal to 0, then x is free to be anything it wants to be. In other words, x is a free variable. So this is our solution if b is not equal to 0. But if b is equal to 0, then x is free to take on any value, or x is equal to t, and that's going to mean y is equal to 1/2 t. So when b is equal to 0, my n sub t vector is anything that looks like 1/1/2 times t.